Okay, we're going to try to work on the next example. The next example is about budget assignment. Consider there is an objective for a company uh, that can incorporate 5 projects. There is a budget um, limitation for this company that it wants to maximize its own profit, but due to the limited budget, it cannot incorporate or use all of these 5 projects. So it has to choose wisely between some of these projects. What should it do? Um, so you can see the data of costs of incorporating each of these projects and the profit after using these projects. So the objective function, as you know, is to maximize the profit. There's 5 kinds of projects or 5 kinds of scenarios for us, right? And there's some kinds of indices and parameters. We will discuss the indices in the CPLEX, but the parameters in here can be something like the profit, the cost, and the limitation of our budget, which is 170. I haven't mentioned it in here, but it is 170 or 150. Yes, 170. The budget is 170. For example, in $1 million. Okay. I'm not saying the numbers are accurately correct. Uh, there has been a change in the currency mark, so the numbers may seem a little too far. So we are just trying to focus on the concepts, not the numbers. And the numbers are not real. In here, so we have 3 kinds of parameters. The one of them, which is budget, is just a number, right? 170. But the other ones, they are sets of numbers. What do I mean? I mean, like for the first project, the cost of first project is $55 million. The cost of second one is 45. There is difference between the cost of each of these projects, right? And for the profit is also the same. So we have to define it in CPLEX in a way that contains all of scenarios in just one parameter, right? We will discuss it later in the CPLEX. So and after that we have decision variable. Decision variables. Our decision variable should be xi, and xi in here may sound a little bit tricky for you because it's not. You see, you want to select or not select a project, right? You want to see if, for example, project 1 is good and profitable for us, is the most profitable for you want to find out the most profitable combination, right? So if, for example, the first 3 projects are the best projects to select, and they will give us the maximum profit, and they will be satisfied through constraints. So these 3 projects are feasible, but these 2 projects are not viable, right? We can't use this one. So the concept of this kind of decision variable is actually talking about some kind of number which is Boolean. Boolean variables are some kinds of 0 and 1 ones variables that can use in such situations, and we are using these Boolean variables in here. Feasibility for unviability of a project. We have 5 projects, so xi should be between 1 and 5, right? And after that, we have the objective function of maximizing, and so xi should be multiplied by pi. But why? Why should we just put py in here? The answer is really easy. We want to maximize our profit. So xi is a Boolean number, which can be 0 or 1, and pi is the amount of benefit after implementing each project. So if you implemented, for example, first 2 projects, it can be something like profit for each project is 150, right? It should be something like 100 times 1 plus 50 times 1, and the other ones, which I don't have access right now, so they can be 0, they are 0 times their profit because they are not selected. For example, we will see which projects are selected after the run. So this should be a 0, 2, and yes, this is what it means to use Boolean numbers, Boolean decision variables in here. So it should be a a maximization of xi times pi, and the only constraint of this problem is the constraint of our budget, right? We have a limited budget. It's 170. So xi, um, um, it should be it's the same. It's that like Boolean variable times c, which is the cost of each project. Xi multiplied by c should be lesser or equal to b, which is our budget, and it's better for it to be like equal. But if it couldn't find any equal, uh, like if the combination of projects were something like 140, and it was not feasible to incorporate any other project, it can use that one, right? So we are going to try and run it on CPLEX. We had sets of indices that was between 1 and 5, which I have written in here. We have the parameters. The type of parameters in here can be anything. We know that they are all integers, but I have put float in here because I want to show you that you are free to choose anything, but as you are the writer of the code, you have to choose the best fit for each kinds of parameters and decision variables and objective functions. So it's on your own to choose the type of your parameter. Okay, it's better in here to just put int, but if you had a floats one, you can just simply put float. But in defining benefit and cost in here, which were which consisted of 5 data for each 5 projects, we have to define a set in here, right? In here, what does this I mean? This I means that the first one, these 100, is the profit or benefit for implementing the first project. This I is just refers to this capital I, right? And these capital I's, 1 to 5, each of them are representing one project, right? Project number 1, project number 2, project number 3, and yes. So we are defining them in this. uh, model in this way, and for the cost is the same. And our decision variable is a Boolean variable, right? So we explain it that it's a Boolean variable, and then we have xi, and then we want to define our objective function, which is summation of I and I, uh, and with the multiplication of xi to pi, and then we want to maximize our z subject to the only problem that we had, right? This error is not for this one, it's for the last example, and there wasn't any kind of error, but we are trying to delete this here and run the problem in here. Okay, now, as you can see, we don't have any kinds of problems in the conflicts and relaxations, which I will tell you in the next example. We don't have any kinds of conflicts in this problem, but the solution in here is the amount of objective function. The optimal objective function is 250, and when we scroll down in here, we can see the value of x for each of these 5 scenarios. As you can see in here, we have the first, the second, and the third projects. The combination of these 3 projects are the most profitable project for us to consider. So what was these ones profit? So 100, 90, and 6, I'm sorry, 100, third, and fourth. Yes, 90 and 60 is the profit for them, is the summation of these ones. And just to double check this, the constraint said that the summation of the selected projects should be below the amount of budget limitation, right? So we are trying to add up these 3 projects costs: 55 plus 65 and plus 50. And as you can see, it's exactly 170, right? So we haven't violated our constraint in here. And yes, so this is the correct answer. And sometimes there's no kinds of like ways for CPLEX to uh, give you the wrong answer, but you can check if you have written the you have written the code in a right way or not, and you can check your constraints or anything in here, right? So we can see the chosen um, projects in here and the amount of objective function, and the statistics tab in here. I want to just drag it a little upper. There's no difference. You can, if like in here, we cannot see the graph really correctly. It's because of the, I don't know, because of the scales or anything. But sometimes the scales are really correct, and you can see the statistics really correctly, really accurately.